So welcome to the video. Today we are going to take a look at how to do a Wilcoxon signed ranked test on version 31 of SPSS. So we're usually going to use this test when we have a within subjects or within participants independent categorical variable comprised of two levels, and when we have a continuous or ordinal dependent variable. So for this example, we are going to imagine that we are interested in how high people can jump vertically, so their vertical jump heights, before and after plyometric training, so training that involves body weight explosive movements. So in this column on the left, we have their heights jumped vertically before the intervention in centimeters, and in this column on the right, we have their heights in centimeters jumped vertically after the intervention. So let's take a look at how we can put these data into SPSS. So the first thing I'll do is go down to variable view, and then we'll just give a name to one of the levels of our independent variable. So let's just call this before, so that's going to stand for before plyometric training, and then we'll put after in the row below that. Next, we'll go over to this measures column and we'll indicate that we have scale data. However, as I mentioned before, we can also do this analysis with ordinal data. So then we'll go down to data view, and we can see that before and after appear at the top of these two columns. So we can just select all of our data in this Excel spreadsheet, and then I'll go to Command or Control C to copy those data. Then I'll go to the top left cell in SPSS, and I'll go to Command or Control V to paste those data in. Sometimes that won't work, in which case you can just go to Edit and then down to Paste, which should do the trick. So once we've got those data in, we're ready to run the analysis. So let's go up to Analyze, and then down to Non-Parametric Tests, then over to Legacy Dialogues, and then over to Two Related Samples. And we can see that we have Wilcoxon already selected here, so we just need to move both of these over to these two spaces here, so we can select them both and then go to this arrow to move them over. Next, I'll go to Options, and I'll tick Quartiles so that the output contains median values for both of those time points. Then I'll go to Continue, and then to OK to run the analysis. So that runs the analysis, but I'll just show you how to create a graph quickly. So we can go up to Graphs and then down to Chart Builder, and we can just close this by going to OK. And I'll double click on this simple chart option here, and that will appear up here. Then I'll transfer before to the y-axis, and then I'll transfer after to the y-axis as well. If this comes up, you can just close it by going to OK. Something to bear in mind is that this process of dragging the variables over to the y-axis won't work if you have ordinal data selected in this measures column. So even if you have ordinal data, I would just leave it selected as scale so that this process I'm describing here still works. So I'm just going to use this menu here, and I'm going to ask SPSS to create bars within the graph that represent medians rather than means, because we usually use medians when we're using non-parametric tests, such as the Wilcoxon signed ranked test, that compare differences between groups or conditions or time points. So we'll select a median there, and then we'll go to OK, and that will create the graph for us. And then if we want to edit the graph, we can just double click on it, and that opens this chart editor. If we double click on the bars, that opens this properties menu. If we go to bar options, we can change the width of the bars by using this thing. And if we go over to fill and border, we can change the color of the bars by using this palette here. And any text we want to change, we can just click on it. For example, we might want to choose a different font style, and we might want to choose a different font size. And any changes that you make here are saved automatically, so you can just go to this red button when you're ready, and you'll see that those changes appear in your output file. So let's take a look now at how to interpret the results of the test. So firstly, I'm going to look at this descriptive statistics table and at this median column. And we can see that before the plyometric training intervention, we had a median jump height of 43 centimeters, and after the intervention we had a median jump height of 48 centimeters. So we can see that the jump height increased after the intervention, and then we can consult this test statistics table to determine whether that difference is significant. So specifically, we can look at this asimp sig two-tailed row, where we can see that we have a p-value or sig value of less than 0.001, and as this is less than 0.05, it indicates that there was a significant difference in jump height between those two time points. So that's essentially how we interpret the results of the Wilcoxon signed ranked test, but let's now take a look at how we can write out those results. So I have an example here, and I've said that a Wilcoxon signed ranked test revealed that vertical jump heights were significantly higher after plyometric training compared to before, and each time I've referred to a time point, I've included these medians. So we have a median of 48 and a median of 43. So as we saw before, those come from this descriptive statistics table. So we had a median of 48 centimeters after the intervention and a median jump height of 43 centimeters before the intervention. This table also shows us that we had 15 observations or participants in this case before the intervention, and we had 15 observations or participants after the intervention. And that has been reported here and here. Next we have the Z value of minus 3.47, and that's coming from this test statistics table where we have the Z row, and we've just rounded this value here to 2 decimal places. We also have this p-value of less than 0.001, and as we saw before, that comes from this asymp sig two-tailed row of this test statistics table. Lastly, we've said that we have a large effect size and we have an R value of 0.63. So SPSS doesn't actually provide us with this value, so if we want to report it, we have to calculate it ourselves. And in order to do this, we take the Z value while ignoring any minus symbol that might be in front of it, and we divide that by the total number of observations. So we had 15 observations after the intervention and we had 15 observations before the intervention. So if we just go to Google, we can put the Z value here, and then we can ask Google what is the result if we divide that value by the square root of 30. And we have this value here of 0.63 rounded to 2 decimal places, and that's what we've reported here. So the last thing to look at is why I've described that effect size as large, and that's based on these criteria that Cohen put forward in 1988. He said that an R value above 0.1 can be described as small, an R value above 0.3 can be described as moderate, and an R value above 0.5 can be described as large. And since 0.63 is greater than 0.5, I've described that effect size as large. So that's about it for the Wilcoxon signed ranked test on version 31 of SPSS. I hope that was helpful. If you have any questions, let me know in the comments, and I will try to get back to you. Thank you very much for watching, and I'll see you next time.